Welcome all. This is our continuation of lecture number 2. We just introduced the meaning of data mining in our lecture 2 with a very short video, and you will see some of those slides repeated in this video, but with more detailed about the concept of using the data and what is data and how we deal with data in data mining techniques. I would like to mention here that I added the copy of chapter 1 and 2 in Blackboard. However, I would like you just to skim those pages, not to read them and memorize them in details. It's more your responsibility to rely on the slides that I am adding to Blackboard and on the videos. So most of the questions that I'm gonna ask, or all the questions that I'm gonna ask, will be based on the video and on the slides that I provide in my course, or from resources outside our course based on articles or research paper from the internet. Okay, so let us start now and talk more in details about data mining. We mentioned a little bit about the major task that data mining take under consideration, which is classification. And here what we meant about the classification is to be able to identify or predict what class that we are talking about. So it's a prediction method. However, clustering is more a descriptive method. We describe our data and we try to find the cluster that are the most suitable for our data. Association rules also is considered as descriptive. Sequential pattern discovery descriptive. Regression also is descriptive. Deviation detection is predictive. We are predicting what kind of deviation from the major samples. For example, if you have a fraud detection, so actually you are looking at some outliers and you are trying to predict it. Regression models, just to give you some examples here, because I know you don't maybe have some statistical background. Let's say that I have my data set as a following, and that my data set is I have the X and Y, where is maybe the size of the houses is on the X. Okay, so and just is converted to like this is size number 2, numbers is 2, 1 and 2 and 3 and 4 and 5, and has specific meaning, each one of them. And the Y is the prices of the houses. And based on this study, they found that, for example, that the cost of this house is here, the cost of this house is here, the cost of this house is here, and the cost of this house is here, and the first category maybe it dropped down a little bit here. Okay, and let's say I bought a house and my house in the range in this. However, I can create a function somehow to describe this type of data. Is not a linear function. Maybe this is a function that simulate this type of data that being gathered. This one is a little bit deviate from the regular function, but this is the best fit that for my function. And as I said, let's say my house is in this area, so if I want to predict the cost of my house, how much it's worth in the market at the time being, so I can know how much it is. So this is type of regression model that we are talking about. You are having a sample of data, and based on this data and based on the variables that you have here is a very simple model to just 2 dimensions, and you create your function. Based on the function, you are predicting a future value. And for the other classification, since we're going to talk about it in more details, this is the only one that will not be described in those slides, so I wanted to show you just a little bit the concept of the regression. Regression is not far from what you understood from the meaning of the regression is predicting the future value. Sometimes regression is used in most of the business model for example, they accumulate for example, the progress or the outcome over the last 5 years, and they plot it as we did here, and accordingly they predict the value of the next year, and this is what they name it, the regression function or the projection function. Okay, so classification is one type of the method that data mining is concerned about. Now, how we are dealing with classification. Usually in data mining, always you have two types of data sets. You have training sets and you have something they name it test set. Okay, so let's say that you have multiple data from multiple years, okay, from 2008, 2009, 2010, and you want and you have 2011, let's say, the following. Now you want to create a classifier to find a specific attribute. So your data set consists of multiple attributes. One of them is a class, and we're gonna see in the following slide what the meaning of the class. And based on the training set, your goal is to create a model, is to create some automatic model that you can use it in future to predict some data set that we don't know their class yet. So let me show you, for example, the following data set. Okay, let's say that we have this table, and in this table it's a transactions table. Okay, and we have multiple attributes. The first attribute is a refund, and since it is yes, no, it's only binary value, so it is categorical value. The second one also is a categorical value. It has a 3 value, single, omit, or divorced, so is also another attribute. The third attribute is a taxable income, so each one of those that shows each one of those user, the ID user, so those numbers are just identifier for the user. And here they are predicting if that user is really filling out his taxes with the right value, either he is cheating or not. So this is the class. So when we are talking about the classifications, our goal is always we have just one column that we are interested in to create our model based on the whole attributes that we have before. We may have hundreds of attributes, and we may have thousands of data set or rows records that we collect our data with. However, in the classification you have one class, and based on this class it might be different class. Here in our case is the categorical type of class, yes or no, and based on the data, and this is what we name it here, this is our training set. So for the writing is not so good. So this is our training set. We train our data, that means we run the algorithm until we find the class that is suitable. Now we have a new data set that comes afterward that we really don't know if, like this data, we know that the person cheated or not in filling his taxes. However, we have a new data set, okay, and this is a test set, and we want to find the class that identified. This is a class. We want to find the attribute of this class. This is very important, for example, in, as I said before, also in the credit card. This is how sometimes either you got accepted or you got rejected. They compare your information to previous data sets that they had, and they match your profile. So this is a profile. This is each row of those is considered a user profile. So this is a user profile. So they match your profile with the majority of those user profile. Let's say we have 100,000 row of records, and let's say we have 500 of those rows that are very similar to your record, and they look at the class value, how much from those class the answer was yes or no that matched to your value, and accordingly they're gonna fill this field over here. So this is the old technique, and this is an automatic system, like you will have a software that will do the job for you. So this is like a simulation for what is all the classification do actually. So actually you have a training data set first, and then you run your model, and we have a lot of different kind of classification techniques or algorithms that you can use to classify. All of them serve the same purpose, which is create a model. So you create a model, and then you plug your new data set in that model, and you come up with the result, which is a class. So I hope the classification, as you can see, is very simple concept, and usually is very easy to be run, and it doesn't take a lot of memory from most of the applications, unless your data set is really huge. Okay, let us give some examples or application on classification. One of them is direct marketing. So the goal is to reduce the cost of mailing by targeting a set of consumers likely to buy a new cell phone product. So what we have here, technically, we have a huge data set about all the people that for example, in the area that you are living in, and they wanted to send a mail for each one, and they want to see who is gonna buy a cell phone or not. So what they did, they used a similar product data that they had it before, like we saw in the previous example, and they looked at these customers and they classified them into two classifications, either buying or don't buy. So instead of having it like previous example, yes or no here, okay, the only difference here we have buy or don't buy. So this is our class attribute. Okay. What they did, they collected various information, demographic information, lifestyle, the company interaction related information about such customers, and the type of business, where they stay, how much they earn, and they use this information as input attributes. So the input attributes here, like here, refund, the marital status, the taxable income, those are the attributes. They use them. Instead of those, they use different, which is the demography and the lifestyle, etc. Those are the attributes that they use to be able to build their classifier. And as we said here, the classifier in this case, either the customer is going to buy or will not buy, and the goal is only to send mail, otherwise will be very cost-wise for the company to send mail for all the for resident of that area. So they only want to send useful mails to those customers that most likely they are gonna buy a cell phone. So this is one type of application. The second type of application for classification is a fraud detection, and which is really popular. So what is the goal? Is to predict if there is some cases of a fraud where in the credit card transaction. So what kind of approach they are using? So use a credit card transaction and the information on its account holder as attributes. So this is all the information that built on or upon the information the customer gave to that bank account. So when does a customer buy, what does he buy, how often he pays on time, etc. And all those is automatic system, is not manual, of course, because they have hundreds of thousands of users. They cannot track them manual. So label past transactions as a fraud or fair transaction. This is the two classes that we have. So we have two type of values for our class. This form of the class attribute in our case. We are creating the model based on the transactions. Then we use the model to detect fraud by observing the credit card transaction on the account. So if they see any different transaction than the previous behavior that specific user used to do over those years in his account, then that will be considered as a fraud, and then maybe either the account will be blocked temporarily, or they will call the I will send the email or call the customer and tell the customer that there is a suspicious of having some kind of either your card is stolen or there is some suspicious with some kind of behavior on your credit card transactions. Another very important application that can be considered also as a part of classification, so we are here concentrating again on classification methods, which is customer attrition or churn. So what is the goal in this case is to predict whether a customer is likely to be lost to a competitor, and this is what, for example, Apple doesn't like to lose their iPhone users to Microsoft phone or to Android, for example, from Google. So the approach is to use detailed record of transaction with each of the past and present customer to find attributes. How often the customer calls, where he calls, what time of the day he calls most, his financial status, and his marital status. So they collect all this data and they run the algorithm of the classifier. They label the customer as loyal or disloyal. So this is the class attributes. We have two types of attributes. Find the model for loyalty. So they find the model, and accordingly they know that those are the customers that they are loyal and they're gonna stay with the same company, and maybe they will provide them with some kind of discount if they add another line, and they try to tempt them to keep them in their loop. A fourth application in classification, for example, the Sky survey cataloging. So what is the goal? Is to predict the class or star of galaxy. So here we want to define either it is a star or it is a galaxy based on the sky object. So especially visually faint ones based on the telescopic survey images. So it's based on the size of the images that they took and the on multiple attributes that can help us to define is it a star or is it a galaxy. So the approach that they follow is the following. They segment the images and they measure the image attribute, which is features, and in this case they had about 40 types of objects. They model the class based on these features, and then they could find about 60 new high redshift quasars. Some of the furthest objects are difficult to find, so some kind of attributes that can help them to define the differences between those two kind of attributes in the class. And we saw that picture before. Now the other type of, and we're gonna go into those as applications and we're gonna run data, but at the time being I want you just to build the foundation of understanding those concepts with a simple approach to start to distinguish each concept separately, the differences from now, what the classification is all about, what the clustering is all about, what the association is all about. Then when we run our data, we will be able to analyze the data based on the concepts that we understood. So the clustering, it's a little bit different technique than the classification. Clustering, we don't know the class. So in this case, we don't know what our class is, and we don't know how many variables or category in our classes. Let's put it in this way. For example, when we went to our first example, we had the status of cheating on our taxes was yes or no. We know we had binary attributes, either yes or no. In clustering, we don't know from the beginning how many clusters our data is going to end up with. We may end up with 3 clusters, we may end up with 4 clusters, 5 clusters, and then we name those clusters. So we have a distributed data, and what we want to do, we want to find similar attributes between those data and cluster them, put them together to find the best match. So given a set of data points, each having a set of attributes and a similarity measure among them, and then the goal is to find a cluster such that data points in one cluster are more similar to one another, whereas the data points in separate clusters are less similar to one another. And similarity measures, there are a lot of different similarity measures. The most famous one is the Euclidean distance that can be used, and other problem-specific measures is based on the type of the measure that you're using, and we're going to see some kind of different type of different measures. But the most famous one, and definitely you heard about it from the high school, the Euclidean distance. So here is an example of that illustrating the clustering algorithm. So here, as you can see, we are in 3 dimensions, but we can recognize that we have 3 clusters. And the goal here is that to have the intra-cluster distance are minimized, that this, like the distance from here to here, is the minimum, whereas the inter-cluster distance are the maximum, like the distance from here to here is the maximum, or from here to here, or from here to here. Okay, so that the goal is to find the similarity. Of course, we color them in different color, but usually they are not colored in different color. And now you are looking at it in 3 dimensions, but if I switch this 3 dimension for you in different way, you may not think about clustering those items in this way. You may cluster them in totally different way. Like if I turn this around, you may see this cluster is on top of that one, and you put those 2 together, and maybe you will see this one separate. So it's really based on the view of the class. That's why it's very difficult when you work on for attributes more than 3 dimension space. Very difficult for the human being to distinguish the clusters, and here is the job of the software to find the clusters for you. Where is the application that use a clustering algorithm the most? Market segmentation. Okay, so the goal is to subdivide a market into distinct subsets of customers, where any subset may conceivably be selected as a market target to be reached with a distinct marketing mix. So how can we do that? Okay, the approach is collect different attributes of customer based on their geographical and lifestyle related information. Find a cluster of similar customers. So here we are collecting the customer that they are based on those attributes are similar to each other, the attribute that we mentioned here. So based on that, we are mixing those customers together. Measure the clustering quality by observing buying patterns of customers in same classes versus those different clusters. So the goal is mainly the measure that we're going to use, the Euclidean distance measure that we're going to use here, is to find the quality of observing buying patterns. So we are searching for the patterns in the customer that they have similarity in between them, and we put them in the same cluster against the one that they are not having the same buying similarity and pattern in similarity in different clusters. And here we are talking abstract, and we'll go in more details in the future. The other one application that very famous, also very famous, is the document clustering, and you see this recently very important, especially in the customer services, because for example, you have forums for eBay, for Best Buy, for many different industries, that they use a customer's forum to write their opinion, and there is no way manually or by human to categorize those input that the customer talked about the product. So the technique that they use, there is an automatic system that will take those texts that the user put in the forum, and then they input them into a specific clustering software such as gPruto, and then you keep running the algorithm until you end up to separate those documents into different documents. Some of them will be based on the product. Let's say we have three different type of products only. This is a minimum example. Like let's say a TV and maybe dishwasher and maybe the radio or DVD player. So those three type of product. Then you have the user's input, which is either will be negative or positive. So based on those three type of products, you are splitting them into two types. So you end up with at least 6 clusters. The good and the bad. Sometimes it's very difficult to find the distinguish between the comments that users leave, because sometimes they are maybe sarcastic. So they will say for one product, "Oh, really? It's really good product," and they put exclamation mark at the end. And if your software is built based on putting the word good as a category as a positive, then will not distinguish if this forum was good or bad. Really, it would be an outlier. And here where the human touch need to be interfered and relook at the clustering and try to take off the wrong one from the right one. So still is not a very effective area, and there is a lot of work in this area of research, and a lot of algorithms still built on top of it. Okay, so the goal is to find a group of documents that are similar to each other on the important terms appearing in the term. So in them. So this is the important terms that based on it. The approach is to identify frequently occurring terms. So here it's based on the frequency of the term, frequency of the word that appeared in the document, and form a similarity measure based on the frequency of different terms. Use it to cluster. What we gain from this kind of application: information retriever can utilize a cluster to relate a new document or search term to cluster documents. So here, like it's like we did with the classification, when we said we have a training data set and we have a test data set. So we built our clusters. Now we know what we have. We separate them. We know which one belongs to which category or which cluster. Then we can come up with a new document and try to put it in which cluster. We decide either to belong to this cluster or to this cluster or to this cluster, and accordingly, based on the similarity between this new document to those documents that are inside those clusters. Okay, this is very simple illustration of the document clustering. So the clustering point, we had about 3,204 articles of Los Angeles Times. Similarity measure how many words are common in this document after some word filtering, and this is very typical because most of the words, they need to be filtered out, especially the common word, which is they name them the stop words, like the, like a, like them, like all the articles, all the conjunction words that they are not important, those usually will be taken off. So they categorized those 3,204 documents into the following documents. So we have here 6 categories, and those are the documents, that the total document that they found and correctly placed. Like after they run the software and they saw the accuracy of the software, they found that really the correctly placed are those. And you can see here the accuracy is not so high. For example, look at this, how bad it is. So as I said, it's ongoing process in this area, and a lot of work is need more enhancement in the text documentation. Is not an easy process. The third type of algorithm, so we passed the classification, we passed the clustering, now we are talking about association rules. We mentioned it briefly in the previous video, and here we're going to talk more about it. The same example we talked before. So as you can see here, the transaction ID number, and we noticed that we have items that this customer number 1 bought, customer 2 bought, the third, the fourth, and the fifth. And what kind of rules we observe: that if you buy a milk Also, you buy Coke. If you buy diaper and milk, most likely end up buying a beer. So this is how the market analysis and predictive analytics use this kind of association rules to predict the future, to predict what the future user or the future customer is gonna purchase. Association rules as application 1. So the marketing and sales promotion, this is the most used, as we said. So let the rule discovered be bagels, and then we have potato chips. So potato chips as consequence that can be used to determine what should be done to boost its sales. Okay, bagels in the antecedent, that means can be used to see which product would be affected if the store discontinues selling bagels. So all this kind of analytics of customer analytics and business analytics tool. Bagels in antecedent and potato chips in consequence. So the result is can be used to see what products should be sold with bagels to promote sales potato chips. So all this kind of analysis helps the industry to know how to promote their sales and to market their products. Another type of application, for example, supermarket shelf management, where to put the products, and this is really key in most of the big, huge warehouses. The goal is to identify items that are bought together by sufficient many customers, as we saw the example of the milk. The approach process the point of sale data collected with barcode scanner to find dependency among items. So we have to look at the item and see which one depends on the other one. A classic rules: if a customer buys diaper and milk, then he is very likely to buy beer. So don't be surprised if you find 6 packs stacked next to a diaper. Okay, that was the old way of using this kind of techniques. In the current way, they are just changing the technique, that they are put them far apart so the customer can see other type of product to buy in his way to look for the associated item. The third application for association rule is inventory management, and this is also very important. So the goal is a consumer appliance repair company wants to anticipate the nature of repairs on its consumers' products to keep the service vehicle equipped with the right part to reduce the number of visits the customer goes to the household. The approach processes the data and tools and parts required in previous repair at different consumer location and discover the co-occurrence pattern. So they are just discovering what happened previously to be applied for the next pattern that appeared. So finding the pattern, the related pattern. A very common recent topic is a sequential pattern discovery. Here we are trying to find a relationship between items, but based on time, for example. So the time is a constraint in this matter. So like we'll see here, there is a similarity between those two. Okay, so first the customer, for example, bought A and B, then bought C, then bought D and E. Here the same A and B, then C, and they are taking under consideration the time that being used in between the product, and accordingly they are defining a new pattern that governs this timing constraints. Also in sequential discovery, for example, in telecommunication alarm logs, for example, like for example, the problem of excessive line current, so rectifier alarm or fire alarm. In point of sale transaction sequence, for example, computer bookstore, how gonna put the items next to each other. We know that we had in the past introduction to Visual C, then C++ appeared, then we had the Perl for dummies, etc. So it's like sequential pattern in the bookshelf, for example, here, or transaction. Aesthetics apparel store, also they notice this kind of sequential pattern, shoes and racket and racquetball and sport, that give us association rules that says a sport jacket, that whoever purchase those two items at the same time here, this one and this one most likely will be purchasing this one in future. So this is some kind of sequential pattern. Regression, we talked a little bit. I showed you the example previously. We're going to talk more about it here. So predict the value of given continuous valued variable based on the value of other variables, assuming a linear or nonlinear model of dependency. I gave you the example of houses and the cost of the houses. So greatly studied in statistics, as I said, it's more in statistic area and neural network field. So predict sales amount of a new product based on the advertising expenditure, predicting wind velocities as a function to temperature, humidity, air pressure, etc. Time series prediction of stock market indices also is being used. Mostly in the market is very popular in the business arena to see the regression model, and most of the statistic after they work on the finding the normal distribution and finding analysis of the data, they end up building the regression model to predict the future of the product, what they name it the projection of any sales or product. You saw this picture also before. We're going to talk a little bit more about it. So deviation, we mean like something abnormal and anomaly detection, mostly in the credit card fraud detection, network intrusion, which is somebody hacking the internet. This is how they can find some similar behavior than the previous behavior over the web, for example, or over the transactions. So what is data in general? So we can name a lot of names appear. Some of them will name those objects, some people they name them records, some of them will name them rows, many different names. Each software will name them differently if you look at the tutorial, but the concept is the same. The same with the attributes. Some of them will name them attributes, some of them will name them variables. If you are using databases or you are using programming languages like Java, you name them variables, but the concept is the same. So here, as you can see, we have, for example, the refund, yes or no, binary type. We saw this example before actually. So it's really simple, just to know it's collection of data object and their attribute. This is the data. An attribute is a property or characteristic of an object. So for example, eye color of a person, temperature, etc. This is a characteristic of an object. Attribute is also known as variable, field, characteristic, or feature. So you can hear those terminology, different kind of terminology based on the arena that the person is talking about, the data mining. If he comes from the statistic, he will use the attribute. If he comes from the soft engineering, he will use the variable. If he comes from the databases, he will use a field, etc. A collection of attributes describe an object. This is in general. Object is also known, which is object is one of those, or row, or record. So object is also known as record, point, case, sample, entities, or instance. So sample is most likely in statistics. Record is more in database. You see this terminology. Point, if you are talking about a graph, so this is a point in this case 1, 2, 3. You have a 3-dimension domain and you are classifying in the 4th dimension. Attribute value. The attribute value are numbers or symbols assigned to an attribute. Distinction between attribute and attribute value. So we have attribute, which is the name of the attribute, and we have the value that assigned to that attribute. So some attribute can be mapped to different attributes value. Example, height can be measured in feet or meters. So, but in your data set, you have to decide which measure you're going to use. Different attributes can be mapped to the same set of value. For example, attribute value for ID and age are integers, but properties of attribute value can be different. For ID has no limits, but age has a maximum or minimum value. So both those attributes can be classified under the same type of category. Both of them are integer, but one of them is limited. Like the age, you cannot go more than 150 or 160 years old, let's say 200, but actually in the ID number you may go to any number you want, which is the identifier number of the customer, for example. What else? What kind of type of attributes we have? So we have the nominal attribute, which is that any number you assign, for example, ID number, the zip code. So if you remember the zip code as a nominal, so this is, you will never forget it. The eye color, so you may have it like a brown, you may have it brown, you have it blue, you have it black, okay, etc. So it's some kind of nominal, we name it. Ordinal, so we have here the concept of ranking. The ranking is important here. So for example, tall, medium, short, so there is some kind of ranking included inside. That's the difference between the nominal and the ordinal, and both of them are qualitative type of data. Whereas a quantitative type of data, interval and the ratio, for example, the interval, you have calendar date, temperature. For example, the calendar date, you have, it's make big difference that you have an interval between date and other date, etc. The ratio, for example, temperature in Kelvin, length, time, count, numbers, for example, so we are counting, so those are considered as quantitative data, where those are considered as qualitative data. Okay, properties of attribute values, you can see either they are equal or not equal, so this is how you can distinguish between them. Order, bigger or less, or smaller, or addition, you can add sum or minus, multiplication or division. Nominal attribute, most likely they are distinctness. Ordinal attribute, you can apply the order and the distinctness. The interval attribute, distinctness and order and addition, where the ratio you can apply all the 4 attributes that we mentioned before. These are just general information. You may not end up using them, but just to give you some more insight, especially for those of you that never heard about statistics before. Usually the nominal data, you have some more descriptive information about it. You apply the equal or not equal, so this is usually very similar, very typical type of examples. So you have 2 types, female and male, as a sex attribute. And usually the operation, the statistic, you use a chi-square test to test this kind of data. Ordinal, for example, you have here as a sample, good, better and best, 3 types of values, and usually you use the median, the percentiles, and rank correlation. So the correlation is mostly used for testing, and you can run tests, and sign tests is very popular. From the quantitative, the interval, for example, as we said, the calendar dates and some others like the temperature. Here you can apply the correlation, Pearson correlation, and t-test and f-test value, if it's or theta value also is very famous. The ratio, you can apply the division and multiplication in addition to the other. We said the 4 type of distinctive type of operation we can apply to. For example, give you a very simple example. It's the age or the count, and here you can apply different operations like geometric mean, harmonic mean, and percent variation. As I said, don't really concentrate a lot about those data, but just to distinguish those kind of difference attribute when we see them in our data. Okay, and this is more deep example. You can look at it and see the differences in it, and this is from the statistic actually is coming. We talked a little bit before about the data in general. So we have 2 types of data, either discrete data or continuous. So discrete data has only a finite or countable definite set of value. For example, zip code. There is a finite number for the zip code. will not go forever. Okay, it will not go to infinity. Continuous attribute has real numbers as attribute value. Example, temperature, height, and weight. Practically real values can only be measured and represented using a finite number of digits. Okay. Continuous attributes are typically represented as a floating point variables. And here we can distinguish between those two because different kind of algorithm will be applied for each one of those. So what kind of data set that we have to be able to use in data mining? So we have the record, and we can say that we have the data matrix. If we have some kind of data that has attribute and it has row and record, as we saw before. The document data, we're going to look at how we log those data. We talked about the frequency of the terms. We're going to see how it's going to look. Transaction data, which is, we saw one of those examples. We're going to see more. Now, the graph, we can define the World Wide Web, which is a hyperlink between pages, for example, as a graph. Also from the biology, the molecular structure, we can define it as a graph. Ordered, for example, spatial data, temporal data, sequential data, and genetic sequence data, and we're going to look at each one of those. Okay, important characteristic of structured data. Here we're going to talk about the structured data, that we can get hold of it, and unstructured data, to give you an example, is the web pages, the HTML pages. We have a very popular problem, dimensionality, and they name it the curse of dimensionality, because as more attributes you have, as more difficult for you to mine your data. And that's why they name it curse of dimensionality. You cannot be able to find the patterns as much as your attribute goes more and more and more. That's why they use some kind of reduction. They find which attributes of those, let's say you have 20 attributes, which one of those attributes, if I cancel rule out from my data, will not really make any difference in my data. And that's rule of thumb whenever you run data mining, that first of all you have to take care of minimizing the number of attributes that you have your data to be able to work on it. Sparsity is very, very common example. For example, if you have a document and you are looking for the word, for example, in that document, let's say maybe USA, maybe you say Europe, Africa, okay, etc. And here you are just counting the number of terms that occurred in document 1, the number of terms occurred for document 2, in document 3. Let's say USA in document 1 appeared 5 times. In document 2 it appeared 0, 0. All the documents were only talking about USA. In this one, the word in Europe appeared in document 2, let's say 20 times, and it appeared 0, 0 on all the rest. Africa appears 0, 0, 0. So as you can see, the real data is this one and this one. So you have here a sparse of matrix. All the rest are zeros, and very difficult to handle this kind of data, because to get the meaningful information from this data, you have to anyway, you have to run the whole data. You have to use the whole data, regardless that the data is sparse and empty, most of the data in it. Resolution, pattern depend on the scale. Okay, this is another way of dealing with the data. So you are gonna scale up or scale down based on how you're gonna deal with the data. Record data, data that consist of collections of record, each of which consists of a fixed set of attributes. So this is a record. We saw this example, so we are consider each one as a record. Data matrix, in this case we can define the data as a rows, and in this case, for example, here we have the X and the Y, the distance, the load, and the thickness, and this is another type of looking at the data. Here's the document that I mentioned before. We are looking at the terms. So in document 1, for example, the term team appeared 3 times. In document 2, 0. In document 3, 0. The coach appeared in document 2 7 times, in document 3 1 time, etc. As you can see, the problem here with sparsity, this zeros, that is not so bad, but still like it affects our data. This is how you represent actually any document. You convert your document to numbers, otherwise there is no way to run your analysis on text. Transactional data, we saw also that one. So in this case you have the transaction ID and you have the items that you are looking at. The graph data, if you have a website, how this hyperreference of this page, okay, that it has a title data mining, and this is a hyperreference of the second page that is linked to graph partition, that named graph partition, etc. Those pages are represented as a nodes, okay, and the numbers it represent instead of the name of the page, they have been numbered them. And as you know, some of the pages are like, for example, this page has a link to this page, and this page also links to that page, where in this one also this only this page is linked to that one, etc. So you can convert any logs exist on the web into a graph, and then you can analyze that graph and work on it and find the pattern from it. From the chemical domain, also you can convert any molecular into some kind of graph, and you can define it by numbers. Sequence of transactions, also ordered data, also you can take under consideration, like here items and event, and this is more based on the biology, and you can consider it. Genomic sequence data also, so you can get the data and you can find the sequence in the data, and then you can deal with it. There are also from Pluto, there is another application for the genetic Pluto that can allow you to analyze the data in this domain. Ordered data, also you can talk about the spatial temporal data, and also it's very hot topic where you can run the data and you can find some kind of pattern in the data. Data quality is very important, and always you have to question before working on any data about how much my data is good and how much noise is in this data. How can we detect the problem with the data? And this is the first step that you work on the data before you go into more details. What can we do with this problem? How can we, if you have like for example, a company, Oracle gave you the transactions of all their customers and you found a problem, you cannot say that I cannot solve this problem. You have to find a solution. There is some technique to help you to find the solutions. So we have some kind of noise and outliers. We have missing data, and most important problem, the biggest problem, is duplicate data. And sometimes the duplicate will be not the same naming, so you have to know which one is which to be able to rule out the one that is duplicate. So this is one example of the noise. For example, two sines wave like this, but when you add the noise, completely distorted. Other type is the outlier. If I'm using clustering algorithms, this is a cluster, this is a cluster, this is a cluster, and this is a cluster. However, this one is outlier, this one is outlier. I cannot add it to any of those clusters, so I have to take them out. So the first algorithm I have to run before even starting clustering, I have to say any point that not is far from any other point, just rule them out and take it out from my data set, and I will delete those data. Missing value, reason of missing value, this is some information about why some data missing. For example, people decline to give their age and weight. This is very typical, the most typical example. Attributes may not be applicable to all cases. For example, annual income is not applicable to children. So this is another example. How we can handle this missing data? We eliminate the data object completely, so the whole record either or estimate missing value, maybe based on average, based on median, based on any algorithm that you would like to use, or any statistical value you want to use. Ignore the missing value during analysis, could be replace all possible value weighted by their probabilities. This is another way, like the average or the probability that what this data can be. The duplicate data, as we said, that's a big problem. Data set may include data objects that are duplicated or almost duplicated of one other. This problem happens if more than one company collecting the same data, and you end up with merging those two data, and there is some overlap between those. So you have some merging data from heterogeneous sources. Same person with multiple email addresses. Data cleaning, this is one of the biggest very popular pre-processing type of data, so you can process the dealing of the duplicate of data issues. So what kind of data pre-processing? There is kind of aggregation, sampling, dimensionality reduction, feature subset selection, feature creation, discretization and binarization, attribute transformation. Very, very popular and very important. We're gonna look at the first one only in this video, and we'll continue the rest in the following video, so it will not be very long video lecture. Okay, the aggregation, combining two or more attributes or object into a single attribute or object. And this is how we can reduce our number of attributes. So data reduction, reduce the number of attribute or object, change of the scale. Cities, for example, if we have cities, we can aggregate it to regions or to state or even to countries. So we are really compressing the data completely. More stable data, aggregate data, tends to have less variability, and that's true because in this way your results of aggregation will be much easier to predict. This is one example for the aggregation. So as you can see here, they used the standard deviation average for monthly perception. We're here for the yearly, and as you can see here, we don't see it very clear, this kind of this variation of the data is almost, we can say we have that kind of curve, where here we have, I can say, this kind of curve, small. So it is important. So we're gonna stop at the sampling, and the following video will talk more about the sampling. Okay. And if you have any questions, please email me.